Hello, I am Brandon Chan, and this is my Lab 3 bar magnets lab. An introduction to this lab is, I measured the distance dependence of the magnetic field due to a small bar magnet, and compared my measurements to the distance dependence predicted. To predict the measurement, I used equations derived from the Biot-Savart law for on and off axis. And which of these statements describe what you observed? And I just chose the two that I did observe. When the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction, and as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases, which is basically explaining the Biot-Savart law, which means the closer the magnet is to the magnetometer, the greater the electric field is going to be, and the further away, the less it'll be. This is the data I found for my lab. I'm going to go to the actual Excel sheet so it's easier to look at. As you can see, I found 3 different distances for each strength of the magnetic field that they gave us in the lab. After completing 3 trials for each strength, I found the averages and made this graph. As you can see, the average distance decreased as the strength of the magnetic field increases. This graph shows the ln-bx versus ln-r. The line that this creates will be important for later calculations. This is my data for the off-axis fields. For the calculations, I used the 2 equations given to me in the lab. B equals kr to the nth power, and B equals mu naught over 4 pi times 2u over r cubed. First, I had to find my k, r, and n. So my n would be the slope of the line that I found earlier. The y-intercept of this line represented ln k, so to return it to just k, we had to put e to the that power and ended up with 3.02 times 10 to the negative 13th. After plugging those values in and solving for mu, I ended up finding that mu equals 1.25 times e to the negative 7th, which I later used in my glow script code. That was the number for the magnitude of the magnetic moment found right here. I had to create a function for the magnetic field, seen right here. I made 2 arrows to represent the magnetic field on axis. I made 4 arrows to represent the magnetic field perpendicular to the axis. And I also made 8 different arrows for the magnetic field 45 degrees from the axis. When I run the program, it looks like this, where the pink arrows are the 45-degree angles, the blue ones are perpendicular, and the orange ones are on axis. And all the estimations are at the bottom. I found those calculations to be quite a bit off because my slope is negative 1.9961, and I believe the optimal one was around negative 3. So that ended up skewing my data a little bit. Questions. What if you hadn't oriented your experiment to compensate for the magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The results would have been skewed because the intermediate value, The results would have been skewed because at the intermediate value, the Earth's magnetic field would essentially be combined with the magnet's electric field, causing inaccuracies. By compensating for the magnetic north, we can ensure the x component starts at 0. What if you were to stick 2 identical magnets together, end to end, and run the experiment again? How would you expect your measurements to differ? The magnetic field would be stronger, but less than double because the difference in distance. That is it for my lab. Thank you for listening.